afternoon, everyone. From the beautiful city of Noordwijk, the Netherlands, we still do not know who the next US president is going to be, but we are here to know what is going to happen in the data centers of the future. Welcome to another one, and a special one, edition of the Epic Online Technology Meetings. Oh, there you are. You caught me gaming in the cloud. That would have been unthinkable a few years back, but now optical communication networks made the impossible possible. And not only for cloud gaming, but think about remote medical operations, autonomous driving, hands-on remote training, virtual reality in an open world, and the list goes on. All of this only work when there is near zero latency, a network faster than the human reaction time or the human interconnect between our eyes, our brain, and our hands. And the second challenge is that legacy electronics cannot keep up with the global demand for bandwidth. Parallel channel processing is reaching its limits. While we watch YouTube, Netflix, Amazon Prime, HBO, Disney+, and even the next Olympics in 8K, bandwidth demands are going through the roof. But researchers already know that optical switching is agnostic to the speed at which you are sending information.
What you see in data centers every 3 to 4 years, the entire infrastructure has to be ripped out because there's a new bit rate and we have to change everything. The chip doesn't care what comes in, what comes out. And that's unique to optical switching. And if the next jump is for 800G, you don't care. Whatever comes in, comes out.
So on Wednesday, November 4th, we are organizing a top-level discussion about data center interconnects. What will the optical network architecture look like, and what demands will it put on the physical layer? This is a key opportunity for the companies in photonic and electronic integration and optical network solution providers to find ways to collaborate. We'll have the data center operators like Telefonica or Microsoft in our Zoom room, together with suppliers who are ready to solve tomorrow's challenges today. And I am thinking of a VIP list including Ciena, Huawei, Juniper, Infinera, Adva, and Cisco. So sign up to participate in our online technology meeting or watch it real time on our YouTube channel, because our urgent need for speed is up for discussion. So everybody full of energies, we are about to create business opportunities. That's what this meeting is all about. And what we have to say when we start with this, we have to always thank the support that we keep getting from the industry. Thank you very much. Many of you are aware that a couple of weeks ago, EPIC became the largest photonic association on this planet. So we are extremely happy to have the support of the EPIC members for these 627 members that we have right now at EPIC. Thank you very much, all of you. Our job is to keep knowing each of you individually and trying to find ways for you to contact your suppliers, customers, and partners at our beautiful meetings. Thank you very much for this, and also thank you for all the support that our online technology meetings are having. This is the agenda from now until Christmas. Remember, today we have Datacenter Interconnects, and we are going to have other topics like water quality monitoring, quantum communication, peak testing, all the way to the last meeting of the year, which is going to be on food and beverage, and it's just going to be just before the Christmas holidays. I just want to be extremely thankful for all the community and all the support that we keep getting from all of you. I just want to make sure that you get what you deserve from the EPIC network, and that you, little by little, keep telling us how to do our job, because ultimately we are here to support you. I just would also like to acknowledge that this meeting wouldn't have been possible with the support of our sponsors today. We have a long list of sponsors. First of all, Modulight, all the way from beautiful Finland. They make semiconductor lasers. This company actually has MBE growth themselves, and they go all the way to making semiconductor lasers at wafer level, at die level, and even make instruments that go even to opticians. Tegema from the Netherlands. These people are specialists on the active alignment of components. They make equipment for the active alignment. VI Systems in Germany. These VCSELs got the world record, the fastest VCSELs in the world. And if you want to have any of the laser components, Denselight Semiconductor, all the way from Singapore, this company is the company of choice if you're looking for optics, semiconductor laser, fiber components, from integrated photonics all the way to laser components. And in Switzerland, we do have Axetris. Axetris is a company specialized in the world of micro-optics. And when it comes to micro-optics, these people can actually design optics for the co-package optics for the integration and fiber to the chip, and optics for the silicon photonics hybrid integration of components. And if you're looking for a software provider, you have to talk to Synopsys. Synopsys is accelerating the adoption of photonic and photonic integrated circuit technologies, from software design to manufacture energy efficient, high performance photonic devices, systems, integrated circuits, anything. Synopsys is, of course, your partner of choice. And finally, last but certainly not least, we have SUS MicroOptics, which is a company also specialized in the micro-optics. Europe is leading the next evolution of micro-optics technologies, and these people have actually also integrated micro-optics in microprisms for ultra-fast packaging solutions, and also special features for high-density co-packaging optics. It's also a member of PIXAP, and if you're looking for members of PIXAP, ficonTEC. ficonTEC has positioned themselves in the center of the supply chain of packaging integrated photonics. If you're looking for a specialized company for making the equipment of packaging integrated photonics, you go to Germany, you go to Bremen, you go to Aachen, and you go to ficonTEC, a key company in the segment. And also, I would like to acknowledge our media partner, Fibre Systems. Thank you very much for supporting today, and our key players, our cooperation players, our partners in crime, COBO and Ethernet Alliance. But with all this, I also would like to thank my very good friend and better R&D manager, Ana Gonzalez. Dr. Gonzalez, thank you very much for being with us today. What's in the menu?
Thank you, Jose, for this introduction. So hello, everybody from Barcelona. We have in front of us a really interesting meeting with talks from services providers such as Telefonica, companies that provides vertical integrated networking solution such as Juniper and Futurewei, and companies providing transceiver modules such as Axetris. So as you know, at EPIC meetings, presentations are short, and they are used to trigger the discussions between the entire supply chain in Datacenter Interconnects that is here today. So let's explore new collaborations and synergies driven by the needs of end users. So these times, these end users are service providers that will tell you about the needs. And then we have the companies doing transceivers and optical cables, companies in the data center infrastructure management, the ones offering networking solutions, and surrounding all these, we have all the manufacturing supply chain. Companies offering packaging and testing, companies active in photonic integrated circuits, components and modules, companies offering materials, fiber optic, equipment, software, and much more. Also participating in this meeting, we are very proud to support the European Commission on Photonics 21 initiatives, such as Passion, that develops a very promising technology for metro network solutions, and the pilot lines in photonics, such as JPIC's pilot line that offers services for manufacturing large volumes of indium phosphide chips, also including design and testing. Also the pilot line Fabulous that offers services for free-form micro-optics for large volume manufacturing that can become key to ramp up production of devices in terms of coupling light in a photonic integrated circuits, and the PIXAP pilot line that offers services for packaging and assembly photonic integrated circuits, including optical, thermal, mechanical, and electrical building blocks. And talking about PIXAP, I would like to announce a new open call for the PIXAP pre-commercial rounds. So PIXAP wants to help companies to work with standards and a process that are compatible with large volume production. So please go to the PIXAP website, pixap.eu, and check PIXAP packaging solutions. And if you have some chips to package, apply through the website or send me an email, okay? So all the ingredients for another successful meeting are in place. So let's cook it. Back to you, Jose.
Let's cook it. Thank you very much, Anna. At the end of the day, this meeting is about cooperation. I would like to also acknowledge that this meeting is being live streamed in YouTube. So let me say hello now to the YouTubers. Hello, YouTubers in the world. Thank you very much for being there. Welcome to the EPIC meeting. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I will be more than happy of making that introduction. You can also use the chat in the YouTube stream. At the same time, this is also valid for the people in the Zoom room. We are going to have one one-on-one discussions after the meeting. So you want to have a private discussion with any participant, let us know during the meeting. And also, if you want to get in touch during the meeting, use the private chat. And if you miss a chat to talk to any of your potential partners, suppliers, and customers, also send me an email and I will be more than happy on making this introduction. Let's get the ball rolling. Let's start. And we can start better than with our partner in crime, COBO. Tiger, thank you very much for being with us today. Why is the Onboard Optics Alliance COBO helping, supporting DCI?
Sure. Oh, thank you very much. So let me briefly introduce what COBO is for those who do not know about COBO. But the COBO has started in 2015 to overcome some challenges we are foreseeing for pluggable optics, where we need to increase bandwidth and lower the power consumption. So we are we standardize onboard optics modules that can be mounted mid-board on the just like described on the slide, and that's been the standard is out there for a while now. And now we are taking another task within COBO to discuss about coaxial optics, as the optics needs to be closer to the ASIC to support lower power consumption and increased bandwidth as well. So COBO has a new working group for coaxial optics, which I'm chairing. So if you have any questions about it, please reach out to the website onboardoptics.com, and the COBO has many materials public available. Also, we are having some discussions about coaxial optics, obviously. So we encourage people who has an interest in coaxial optics or anything about onboard optics, reach out to onboardoptics.com.
COBO has been instrumental for EPIC. I would like to thank Tiger and the whole COBO community for this. An initiative that is supported by the top companies in the sector and has been open, always with the arms open, looking forward to receiving input from any company. So anybody who has input for the co-package optics activity of COBO, you can contact them. And I think that was great. We really need to know now about what are the demands for bandwidth. And believe me, there is no better person that I know of than my very good friend, John D'Ambrosia, to take that chance. John, good morning in New York. How are you doing?
I'm doing awesome. How are you doing today, Jose?
You look fantastic. You look right in action. Red, right? It's morning. Everything is okay. We don't know who the president is, but we don't care, because what we care is about the bandwidth demands.
Well, thank you, Jose. And yeah, it's actually a really good time for us to be having this call. I want people to realize that we've heard a lot of references already today to needing more bandwidth, and I wanted to make the EPIC community aware that next week I will be initiating requests within the IEEE 802.3 Ethernet working group to start the next project to start development beyond 400 gigabit Ethernet. Jose, if you could flip to the next slide, please. Just as this is a standards activity, I do need to use these official slides. Essentially, basically, any views I say today about the standard development is my view. So I'm not here speaking on behalf of the IEEE. I'm the champion who's trying to make it happen inside of the IEEE. So Jose, next slide, please. Okay, so the state of beyond 400 gigabit per second Ethernet. A call will be held next week to initiate that effort, and it will be, I don't want to go through all the sausage making as people like to talk about it, but come December, we anticipate that there will be a new effort inside of the IEEE 802 community to start defining beyond 400 gigabit per second Ethernet. And that will be, I anticipate that the first meeting will be held in January of next year. If you want to find information, the presentation explaining why we need to go to a higher speed and the issues with it are at the link there, as well as believe the URL I have here is the URL that will be used for the future study group page. So I want everybody to be aware of that. Just, you know, as I know I got to keep this real quick, let's go to the next slide, Jose. When somebody says Ethernet, you know, this is my third time at starting a new speed, and it seems like it grows every time in terms of what we're doing. And we have this little diagram that I'm showing here today that kind of tries to put a picture in terms of what are we talking about for beyond 400 gigabit per second Ethernet. Now, many of you will recognize that data center style architecture over on the left. And if you look at the different speeds and the different reaches and the different mediums, you can see that we have a very big project in front of us to address a lot of different things. In addition, at the far right, you can see, that's assuming you don't have the video window over it, there's going to be a discussion about coherent optics versus direct detect optics. So when I look at this diagram, Jose, Anna, I see a huge, don't go away, go back to that slide, Jose. I see a huge opportunity for the COBO membership to be getting involved and to be defining and helping to start the next generation of Ethernet beyond 400 gigabit. I mean, just look at the different things that we have to worry about. Multi-mode, single mode, duplex fiber, parallel fibers, all the way up to doing DWDM systems. You know, there's a lot of stuff here that's going to happen. And honestly, it would be great if the COBO community could come together and really start looking at providing the industry with an optical roadmap. You know, there's a lot of signaling going on there, and it's not just about signaling, it's about all of the different industries that will support making these higher speeds happen. It really is an ecosystem style problem, from the components, from the testing. I'm sure there are people on here who could contribute and saying, yeah, you got to worry about this with higher speeds. We need to start thinking about this, because honestly, as we start to look ahead, this is technologies that's going to be down the road in the second half of this decade. So now is the time to start planning that roadmap and mapping out our journey. And with that, thanks everybody. If you have any questions regarding the effort, please feel free to reach out to me. I'll be happy to talk to anybody. Jose knows how to get you in touch with me.
Thank you very much, John. Thank you very much, John, for what you're doing for EPIC, for the industry, for your call for interest, for extra bandwidth. We need people like you in our community. I'm extremely happy to have you as an advisor and as a friend. Thank you very much. Anna, let's continue.
Yes, let's start with the first presentation of today. Well, the third presentation of today. So it's my pleasure to introduce Juan Pedro Fernandez-Palacios, which is head of the unit of Integrated Transport Center at Telefonica.
So thank you again, Anna. I think lots of things I think to tell you today. Short time. I'll try to be fast. I'll present you what is the Telefonica vision about the SDN architecture for open optical networks, and what is the relation of this topic with the data center interconnection. Currently, telco networks, telco optical networks, as the one from Telefonica, are typically based on mono-vendor solutions, where all the transponders, the ROADMs, amplifier, everything is provided by a single vendor in its domain, also the network management system. And if we want to introduce new data center interconnection solutions, as the ones that are being developed in the last years, there are parallel products for data center interconnection that are very cost effective and quite simple, then we always need to go for the same vendor that we have in the network. For example, if we have a Ciena, Infinera, Huawei, whatever network in the domain, and we want to deploy a data center interconnection network or solution, we have to integrate it with the same vendor. Otherwise, everything, all the configuration, performance, protection, and so on should be done manually, because we can provide these alien wavelengths from using data center interconnection solutions, but this is very complex to maintain and operate. The solution, in order to integrate these DCI solutions within the existing telco network while keeping performance monitoring, optical restoration, that is key. For example, in Telefonica, we are using optical restoration at the optical layer for every channel. We don't want to do it at the IP layer. We want to do it in the optical because it's much cost effective. Okay, we can do all these functionalities, restoration, performance, fault management, with an alien wavelength, or for example, a data center interconnection solution from one vendor over the open line system, over the optical infrastructure, the ROADM and so on, from other vendor using SDN. and a standard SDN architecture. And this standard SDN architecture is based typically in two main interfaces: the transport API, and that is offering information about the topology, the network situation, for example, the performance, the fault management, and so on, towards the applications on top, the hierarchical controller or an OSS. And very important also the support of netconf-YANG and OpenConfig models in the SDN controller and also in the open terminals. For example, these solutions, these DCI solutions, should support this netconf-YANG and the OpenConfig. If we have these, the support of these interfaces, these standard interfaces in the terminals and in the controller, then we can manage and operate an alien wavelength as with the same capabilities or with the same characteristics as a regular channel in an aggregated network. Okay, in this case, even if we have an open lane system where the SDN controller from the vendor, from Ciena, Infinera, Huawei, or whatever, is not supporting the OpenConfig in the controller of its network, we could also configure the open terminals with a hierarchical controller on top. So we have a backup in that case. So we can always, the key from the data center perspective or for the DCI provider is to support netconf-YANG and the OpenConfig models, because the configuration could be done by a third-party controller. Important. Okay, we are intensively working in Telefonica on this, but we are not alone. This vision about partial optical disaggregation and the standard SDN is not only a Telefonica issue. Currently, we have recently created a working group in TIP. The name is MUST, and I think the name is clearly explaining the purpose, mandatory use case specifications for SDN transport, where Telefonica, Vodafone, MTN, Orange, Telia, and Deutsche Telekom are working together to specify, to provide the technical specifications that for these interfaces, the technical specification that should be supported by both the network elements, for example, the devices, the transponders, the open terminals, and the SDN controllers. Okay, the idea is this network, or at least this specification, is something that we think and it should be led by the telecom operators, and we are doing that. And okay, in this picture, just to show you that currently in Telefonica, we are hosting the OIF 2020 SDN interoperability demo. Combining, we are doing all the potential combination we can imagine in the open terminal, in the controller domain, in the hierarchical controller, to test and check that the vendors are implementing the technical specifications as are requested in the standards. Currently, we are working on this testing, and we are planning to also to disseminate the results of this test plan in the coming month. Just to conclude, 3 important messages. Current optical DCR solutions are only applicable in monovendor networks. If we want to deploy a DCI solution from, for example, from Juniper over a Ciena network, this should be manually configured and is only applicable in basic point-to-point links. For example, we cannot have optical restoration. However, if we apply an open SDN architecture using TAPI and OpenConfig with netconf-YANG, then we could have multi-vendor interoperability and enabling automated operation in these environments. Okay, that's all my side. Thank you, Anna.
Thank you very much, Juan Pedro. Super nice presentation. So, okay, so I have a question. What do you think are going to be the needs for data center bandwidth in the next years? I mean, from the point of view of Telefonica, no? How do you see also this transference to this online world, no? In which everybody is working at home, no, because of this virus situation? Yes. How do you think it's going to work?
Yeah, I think we are expecting most of the traffic pressure from the data centers at the edge of the network, that is in the metro networks, to the access. And this is the network segment, the metro regional, I think like distances of no more than 300 or 400 kilometers This is metro regional. No more than 300 or 400, and most of the channels, I think 100 gig, 200 gig, and 400 gig. Probably no more than this. In the, for example, capacities above this may be needed for the data center interconnection, for backups, but the demand for these channels may not be so intensive as in the edge, because most of the traffic is moving, or the applications are moving to the edge, and the consumer and most of the traffic will be in this segment. And in this segment, since we have, or the operators as Telefonica we have photonic meshes, we have lots of different paths to reroute the traffic, so we can absorb lots of traffic using multiple paths. According to that, we don't need very high capacity links. We can have, it's better to have granularity, lots of 100 gig, 200 gig, or 400 gig. And the main motivation to deploy a new technology or upgrade to, for example, to 200 gig or 400 gig is cost. It's just the cost per bit. If we have a lower cost per bit for 400 gig, we will go for that in the metro. Otherwise, we can absorb the 100 gig using multiple paths over the photonic mesh.
Okay, so you are asking here new technologies to reduce costs, no, per bit. I think we have a comment from Jim. Jim, would you like to unmute and make the comment by yourself?
Yeah, I can, but just you mentioned net copying a lot. Maybe one sentence or briefly explain how those models are related to the network and why they're important in moving to the SONPA model.
I'm sorry, to be honest, I didn't really catch the question.
So what's a net conf-yang? You mentioned about every other word was net conf-yang, so maybe a brief description.
I'm sorry, yes. Now, very brief discussion. The description, like these are the modeling, in particular the OpenConfig modeling, are the models in order to configure the transponder so that from a controller we could decide what is the power, the wavelength. So in order to configure the basic parameters for the transponder. In that case, for example, we can select the wavelength for a restoration path. These are like the configuration. These are the protocols that enable the device configuration. And if we use a standard one that could be implemented, currently we typically use proprietary interfaces for that. It is going for a standard one that could be, for example, integrated in an agnostic controller so that we can combine channels from one vendor over the optical infrastructure of a different vendor. But this is device configuration.
So if I hear the answer correctly, you're saying we have the capability today to do all that, but to make it vendor agnostic, we need the net conf-yang models so that we can set the same things depending on no matter who's in the restoration path.
Exactly, we can do it now, but this, if we need to do an ad hoc or a specific development or implementation per vendor, this is too expensive. This is too costly. We should go for a standard in order to be vendor agnostic.
All right, thank you.
Welcome.
Okay, thank you very much for this very interesting conversation. So now maybe this is a good moment to see about the capacities for these companies that want to design, want to prototype, or want to test devices working at 400G or 200G. So we have here Giovanni from VLC. Hello, Giovanni. How are you doing?
Hi, Anna. I'm doing fine, thanks.
Thank you for joining. Will it be, maybe it's a good moment for you to introduce what are the capabilities in design, as design house of a VLC. Maybe could you have a slide to show?
Yeah, I have a slide. Let me just share my screen. Can you see it?
Yes, I mean, it's not presentation mode, but it's okay.
No, okay. Now it's in presentation.
Yes, now it is.
Okay, thanks, Anna, for the introduction. So I'm Giovanni. I'm R&D engineer in VLC Photonics. So we in VLC, we consider ourselves a fabless photonic design house. Okay, we have about 10 years of existence. We are located in Valencia, Spain, and you have a network of international partners, many of them in Europe, but also in the USA and Asia. We are a team of 17 people with extensive academic and industrial experience. What basically we do is that we provide engineering services for the development of products based on photonic integrated circuits. So we work with many platforms, silicon photonics, silicon nitride, silica, indium phosphide, and many others. And we provide all kinds of services to develop products in PICs, from system concept to device design, layout, testing, and packaging. So the fabrication is done outside. We have clients in all types of applications, including telecom, datacom, and other types of applications, sensing, signal processing. And we are also involved in many projects, R&D and pilot line European projects. For example, we have Impulse, which is a pilot line for indium phosphide photonic integrated circuits in the JAPIX association. And we are developing, we are actually filling the gaps between JAPIX today, which provides MPW services, to provide pilot line services. And also, for example, PICs for Life, which is in a silicon nitride platform in IMEC. So if you want to contact me to know more about VLC, you have my email address here. Thanks, Anna.
Thank you very much, Giovanni. Regarding indium phosphide chips, regarding the Impulse or JAPIX pilot line, do you think it would be useful to make transceivers that able to reduce this cost per chip that was mentioning Juan Pedro?
Yes, of course. Indium phosphide has many advantages, which is, of course, the benefits of integrating the laser sources and for example, semiconductor optical amplifiers in the same chip. I think in the last years, indium phosphide has improved a lot, the technology. We are getting high levels of yield, and also increasing wafer size. So this can drive down the cost, and of course bring the benefits of indium phosphide, which is the integration of all active functionalities into the chip. So yes, I think it's a great candidate for the next generation of PICs for datacom.
Thank you very much, Giovanni. Okay, so then if there are no more, well, yes, we have a question for Giovanni. So Tobias from Jenoptik, would you like to make the question by yourself?
Yeah, of course. So Giovanni, you said that you also provide testing capabilities and services. And once it comes to high volume production, how do you go with this testing services? Do you perform them by yourself, or do you transfer to somebody else, test house, for instance?
Yeah, that's a great question. Indeed, high volume test is in our roadmap. Indeed, I want to share that we have received a wafer level test machine, so we can now test at the wafer level. And we are also developing automated scripts for testing our chips in die level. So we strongly believe that we'll be capable in a few months to perform high volume testing on several chips, and also wafer level testing. So this is something that we are looking into actively, because you know that for scaling up production, we need a lot of tests. So for the wafer level machine, we for sure will be able to make electrical tests, and we are working on developing also the optical test functionality in the wafer level machine. So this is something that we are actively looking and developing our capabilities for that.
Let me stress this, because this is one actually one unique thing that happened at the Epic, the magic of Epic. Last week, I saw this beautiful LinkedIn post from VLC Photonics. They actually got a machine from ficonTEC to do wafer level testing services. And that has been a gap in the value chain for many years. So congratulations, VLC from Valencia, ficonTEC, working together we are stronger. Thank you very, very much for this. You should talk to Genoptic because Tobias is putting a probe for wafer level testing into different foundry systems, and in my opinion, it has to be incorporated to the VLC wafer level testing process. Thank you very much for that. And I cannot wait for the next speaker because he's also a very good dear friend of mine, Michael Lebby. Thank you very much for being with us today. You are the CEO of Lightwave Logic. You are also in every road mapping activity I ever interacted with in Interactive Photonics, and you have been also helping Epic. Thank you for this and the floor and the attention of everyone today all around the world is to you, is to Mr. Lebby.
Thank you. Let me see if we can get the screen to share. Just want to double check everybody can see that.
We can see crystal clear.
Perfect. I've got two small factors in this presentation. The first one is to the exciting proposition of putting polymers into the data center and to upgrade your PIC. And then I've got a few slides on the work I've been doing with EPIC and Photon Delta AIM Photonics over the last year or so on the PIC industry roadmaps. And I'd like to share some of those roadmaps with everybody today. So let's go to the next slide. And I've got to get through this one because we're a public company. And these slides will be on our website. So just go to our website if you want to see the slides in more detail, especially the roadmaps. So the first slide is really market position in a dynamic environment. An engineering advantage from our standpoint is polymers, electro-optic polymers. And clearly you want to address some of the major pain points facing network operators, especially in the data center. So if you have a good platform, technology platform flexibility, that will actually lead you into the middle box on this graph, which is obviously faster networks. You've got to be able to enable faster networks, and we certainly can generate our own chromophores and polymers here in Denver, Colorado. And we design modulated devices from those. And if you can actually enable some faster networks, then hopefully you can do some energy savings within the network using these types of very low power, very high speed devices. And so what we are really talking about is hybrid PICs, and hybrid from the standpoint of polymer plus. So that's that purple arrow in the center. And this is an interesting graph. On the left-hand side, you've got indium phosphide, which is a PIC incumbent, as everybody knows, you know, with the indium phosphide lasers and passives, and we'll hear about some of those today. Those are the attributes. And on the right-hand side, you've got silicon photonics, which has also now become a big incumbent with a couple of large companies really pushing this technology successfully. But what we're seeing here is that we believe you can upgrade your photonics platform by using polymer modulators, which are very fast and very low power. But how would you do that? I mean, you can do that certainly on indium phosphide, you could do that on silicon photonics. And in this slide here, we're showing three ways to do this. On the left-hand side is your traditional electro-optic polymer modulator, which is your polymer stack, where you typically have a core and two claddings, and that's on a silicon substrate. That is what a lot of people have done in the past, especially over the last 20, 25 years. We've seen a lot of three-layer stacked solutions. And the one in the middle is the one that we are working on pretty hard right now. We put a press release out a couple of weeks ago, what we call Polymer Plus. So instead of doing 3 layers onto a silicon substrate, we've actually simplified the fabrication and put a single layer right down onto an integrated silicon photonics layer. It could be any other integrated photonics layer too. So that's a Polymer Plus. Add in the polymer in the fab onto an existing platform to upgrade your modulators. And the one on the right is a lot of companies, a lot of universities and academics are working on polymer slots. We also have done some ourselves. It's the smallest form factor. These slot modulators are certainly not commercially available yet, but they're certainly showing a lot of interesting performance traits, and they're very, very small. And so polymers, we believe, can deliver radical innovation, certainly faster devices. We've already demonstrated greater than 70 gigahertz, EOS 2.1 bandwidths, very low voltage down at the volt level, which opens the opportunity for direct drive from CMOS circuitry. We very much focused on lower cost, easy fabrication, because in the end, that's the secret to implement a new technology. Can you make it easy? Can you implement it very efficiently in normal standard fab scenarios? And the one on the right, the questions that come up a lot, can you make the technology robust and stable? And we're doing a lot of stability and reliability measurements. So enabling low power, faster, unique, differentiating solutions. Now with that, with a couple of minutes, I'm going to brief everybody on the roadmaps, because I think this is important as we have this meeting today on data centers, onboard optics. So if we go back to 2016, because I've been working in roadmaps for a long time, this is what we predicted in 2016. I know it's a little bit of an eye chart. That's why the slides will be available on our website. And you can see what we predicted for 2020 was 25 terabits, below $5 per gigabit, these sort of metrics. And the same side I'm going to show next is where do we actually get in terms of our assessment. And some of the comments on the right-hand side may be covered by the screen. But what they are is we predicted in 2020 that we would get to 25 terabits. We will be less than $5 per gigabit. We will be using 50 gig devices and even 100 gig devices. We'll be using PAM4. So some of these things that we predicted 4 years ago actually came to fruition. We actually were fairly accurate. And so last year, when we worked on the roadmaps again, 2019 to 2020, where are we going? What's the new metrics we're looking forward at in 2023, 2024? And you can see numbers on that top line. You can see 800 gigs per second. You can see 1600 coming in. You can see less than $2 per gigabit per second. You'll see in a whole section on the variety of PIC technologies, from indium phosphide monolithics to silicon photonics and hybrids, dielectrics, polymers, gallium arsenide. So you've seen a lot of different device technologies are included in this. And this is the last slide is, where do we predict the industry is going for PIC technologies, especially that relate to data center type opportunities in the next 3 years? Well, the top part of this slide, low power is going to be key. Hybrid PICs are going to be key. Faster devices are going to be key. You're going to see devices move towards 70 gigs. You can see folks focus on low power, athermal designs, 100 gig solutions. You're going to see folks come up with 100 terabits per second, one RU. So 2023, I think you're going to see that. You're already seeing people design 25 and 50 right now. And so, from what John said at the start of this session, beyond 400 gig, it's certainly happening. And you can see the technologies below certainly are there to support that. But I think low power and hybrid is certainly going to be some of the key metrics going forward. And that's the end of my slide. Thank you.
Thank you very much, Michael, for a great presentation. And I love this slide with the roadmap. We talk about it. You can talk about this slide for hours, and we will have to, because we really need to use this in many of the EPIC activities. Two things. The first one, in the top right part of the screen, you mentioned 3.2 terabits per second. Is that realistic? What did you base yourself? Let me share that beautiful slide once again. You put the, no, wait. This is the magic of the life. I don't have the slide, but you put in the top left corner, the top right corner, that we are going in 2027 to 3.2 terabit per second. What did you base your research or the discussion with supply chain on reaching that conclusion?
So I think everybody should be aware that, this is not Michael Lebby's roadmap. This is a roadmap where there were a number of meetings, both in the US and in Europe, driven in Europe by Photon Delta, driven in the US by AIM Photonics, INEMI. There was a group of technical experts that certainly looked at where things could go in the next decade. And certainly if we're looking at, taking things beyond 25 and 50 terabits per second. And as you say, going up to 1600 and beyond. What we're seeing right now in the community is people doing prototype demonstrations at 800. Folks are trying to figure out how to do 1600. And certainly when you start looking at some of the challenges, form factors may need to change. Maybe the pluggable needs to change. Maybe we need to really encompass the co-packaging techniques just to really allow us to utilize the technologies in ways that today we're sort of constrained. I mean, if you look at a pluggable form factor, we're constrained a little bit. And if we take some of those constraints away in order to increase the performance and the data traffic, I think there are opportunities here. And certainly the excitement of the folks in the committee that were looking at the roadmap saw ways through this, albeit we don't know the exact technological solutions, but people did feel that there is a route forward.
Together, you and me, we are going to go to Eindhoven because you mentioned Photon Delta. In Eindhoven, we have Photonics networks, and we have a comment from my friend Oded Ratz. Oded, what's on your mind?
Yes, it's a great presentation, Michael. It's excellent to see you. I wish we could meet face to face, of course. It's the idea that we're going to go to 100 terabits, and people have been speculating and doubting whether we can make a 12.5 and 25 terabit silicon devices out of in CMOS nodes. Is it the idea that we have a 100 terabit chip coming from Broadcom soon, or are we hoping to do optical switching instead of layer 2, layer 3 switching?
Oh, that's a really tough question. I mean, when I first came to this country in 1985 about labs, everybody was talking about optical switching, and that was a long time ago. We will see optical switching, but I think, you know, the role of optics is to help the electronics. And if you think about electronics, what some of the big impediments are today, 5 nanometers, getting the power consumption down. We all know some of these 25 and 50 terabit chips actually consume tons and tons of power. So we have to think very carefully about athermal solutions, low power solutions, and trying to keep the speed up. And so I do believe that we will see electronic switching, but I think you'll see optics do what it does best, which is help get those signals in and out of that chip. Now, whether the optics will be on the silicon chip or next to the silicon chip, or a little bit away from the chip, is to be sort of discovered over the next few years. But I do see optics becoming closer to that chip. And we are seeing a lot more sort of proper, what I call proper electronic and photonic integration. It's actually tough to do that, but I think we will see more of that as we move forward.
Michael,
Thanks a lot.
You keep showing this 70 gigahertz modulator, and I understand this is a paradigm shift to go to the 100G channel. Do you think this is the way to go, to incorporating 70 gigahertz modulators in iterative photonics, or there are other potential solutions that you think maybe could also be incorporated?
Well, it's always been a challenge for the industry. And if you think about what the industry's done over the last decade is that they've increased the symbols per bit. So they've gone from NRZ, you know, 1010 to PAM4, and then we've got the different types of encoding schemes that we've seen in telecom. But they're getting more complex all the time. So the question is it's a trade-off. If you start going that route, and a lot of what John indicated there before at the start of the show was coherent, typically requires DSPs, which are expensive. So there's a balance between cost and trying to get the speed of the devices up. And I'm not sure that we really fully understand that yet, except we've done a great job in symbols per bit in terms of PAM4 type solutions. But certainly if we can increase the speed of the devices, keep the power consumption low, there's less pressure on the symbols per bit. So I do believe faster devices, whether they're in silicon, indium phosphide, polymers, or any other material, are going to be important, say.
What I have seen a lot is from many companies trying to reach desperately this 70 gigahertz. I'm not going to mention the companies, but just the technologies. Plasmonics incorporating on silicon photonics, for example, with low TRLs. I do believe that if we need a 70 gigahertz modulator, it's going to be possible with indium phosphide. Definitely, you have proven with polymer. It is going to be a challenge for silicon photonics, which as of today is the platform of choice. And at least that's what I see from the different companies in the higher part of the supply chain. Do you see this as an opportunity to bring new technologies to this market?
Absolutely. If we look at the roadmap, the first two phrases were low power and hybrid solutions. And so pure play silicon photonics, pure play indium phosphide, I think we're going to see hybrid solutions. Folks are going to look at ways to upgrade their platform. Now, I've just talked about a modulator, but I think there's other ways to do that too. And so, folks are going to look for creative ways to do that. We have to get faster devices. We have to get lower power. We have to get better athermal performance. And these are criteria that are not going to change. And so the challenge is on. So I think you're absolutely right, Jose. We're seeing a lot of different innovative solutions there. And this is exciting times.
I wanted to start with you because now we know where we are going, and now we know the challenges, and now we know what the industry is going to look like in 2028. So let's now bring all the different parts of the supply chain. Michael, come with me. We are going to go to Juniper Networks. We are going to get my friend Xianyun to talk to us about how to put all these different pieces of the puzzle together and how to help Juniper be even greater. The floor and the attention of everyone goes to Xianyun, goes to you.
Okay.
Juan, yes.
Okay. Thank you. Thank you. It's nice to meet everyone here. I'm from Juniper, the writer of 400G optical procurement specification. Let me see. Can you see my screen?
Yes, crystal clear.
Okay. Okay. Disclaimer, it's a routine one. Here, I want to first, I want to introduce the progress on the 400G pluggable transceiver modules. Here, these are available form factors on the market. Currently, the mainstream form factor is the OSIP and the KSVDD. KSVDD has 3 types. Type 1, the size of type 1 is the same with legacy KSP plus KSP28. Type 2, the size is bigger. It makes the nose outside of the cage longer. So currently, most modules use type 2. So module integrator could put all the components into this type of KPDD form factor. So from the beginning, it seems the task is daunting because we have a new optical specs such as the PAM4 and also 50G per lane electrical interface. Second, we have a new form factors, KPDD and OSIP. The third, we have this will need a new module management interface. So surprisingly, the progress is quite smooth. So let me go to next page. So we begin from the double density legacy 100G optical ports because we think this would be easier to start. These modules have new form factor KPDD and new memory interface, but legacy optics. So currently, Juniper has qualified 2x100G SR4, 2x100G CWDM4, 2x100G LR4. So double the capacity of 100G optics. Next, we qualified 100G single lambda KB28 optics. This optics could be plugged into the legacy QIP28 cage, and also there could also be inserted into this QIP-DD cages. So with the legacy electrical interface and with the new 100G PAN4 optics, they can interoperate with 4x100G optics of 400G platforms. So currently, we qualify 100G DR, 100G FR, 100G LR1. Next page. This is 400G optics with 50G electrical lanes. This is we collect the whole portfolio of 400 optics with different link distance. Currently, we qualify 400G DR4, 400G FR4, LR8, and 4x100G FR. So actually, 400G DR4 for the same module, it can also can support 4x100G DR. Okay, next page. So I want to introduce the new manager interface of this QFDD or OSIP modules with the effort of the whole industry. We made a common management interface specification. It is now being used by QFDD, OSIP, COBO, QIP56, and SFT DD format with we use a simplified version of CMIS. This new menu interface introduce more customer-facing features. I want to introduce two main new features. These features is quite friendly to module users. One is this CMIS make it possible that for the same module, it can support multiple applications. So each application has a host interface ID and a media interface ID. Hostware just to select different application code. So to swap among different applications. For example, 400G SR8, it can support 400G protocol, right? It can also support 200G SR4 or 100G SR2 or even 850G SR. 400G DR4 could support 400G optics and also could support 400G DR. So this gives the module user flexibility to do the configuration. The next new feature is the firmware update. We all have the experience on the software update of the cell phone, right? Like the cell phone, the devices are more and more relying on the firmware update to, for example, fix the problem or add a new application. So this feature use a CDB function defined in CMIS 4.0 and 4.1. It updatable items include microcontroller code, DSP code, memory map, and so not before we created QIP28 modules. When we found some problem, we have to physically collect the modules from around the world and send them back to the module integrator. So it's not good. So currently with this firmware update feature, so the modules could be updated remotely by host software. So the same software code is applicable to different optics from different vendors. So far, Juniper Host software engineer had implemented this feature successfully, so it's quite straightforward. Okay, this is my presentation. Thank you.
Thank you very much, Xianyun.
Yeah.
Your screen. Okay, so thank you very much for your presentation. I guess that when Telefonica is asking for reducing the cost per bit, you feel the pressure, right?
Yeah.
Fabricating your transceivers. Okay, so let me know, in order to achieve this, in order to reduce the cost per bit, what will be the technologies, what is the aspect of the packaging of the transceiver, or maybe of the design of the transceivers that you want to take into account? I am asking because we have here plenty of companies that want to collaborate with you. So which will be your preferred collaboration?
Yeah, currently all 400 optics, most of them are still using separate components. So to further decrease, I think still need the effort from our side to, for example, the DSP has cost much, right? Also, the power consumption on DSP is large now. So currently, the industry is using 14 nanometer DSP, and currently 7 nanometer also available. So in order to decrease the power consumption, need to continue to decrease the power consumption of DSP. Also, I think many colleagues mentioned the integrated optics, right? So in reality, I think cost reduction is still issue, the mass production, right? So how to make it real to be a mass production technology. Also to decrease the cost below the separated components. Yeah.
Okay.
Still a challenge, yeah.
Well, you cannot imagine how active was the chat during your presentation, so I don't know how to start. Jose, do you want to maybe?
I want to start with Valerie. He made a very interesting comment about co-packaged optics. Valerie was speaking from Intengent, one of the indium phosphide suppliers that we have in our network. Valerie, when it comes to co-packaged optics, you had a very interesting comment. Could you share your mind with the rest? I don't know if we have him online.
I have to unmute. Yeah.
Yes.
Do you hear me?
I hear you and I see you, and I'm so happy to see you.
Hi, Jose, and hello, everybody. Yeah, I don't think it's a very original comments which I made. I believe it's pretty common these days. People who spend, as much time as I did with all these pluggables, ask themselves, where does it go? So I don't believe personally that you can squeeze more than 800 G per lane into pluggables, whatever it is, for C8 or 16. So what's next? So with all these tomahawk switches and likes going into many tens of terabit, what do you do? So I do not see how pluggables can do this. So co-packaging or anything like that, I believe, is logically comes up as a solution. And besides, I believe that if silicon photonics per se has a real advantage, this is where you have this kind of very massive parallel integration, like in these co-packaged devices. So that's the view, I believe, shared by many by this time.
There is a view shared by many, not by everyone. not by everyone. There are many who actually consider CPO as an intermediary step. But I want to steer the pot a little bit here. I'm going to go to John. John, Futurewei, what's on your mind?
Well, I think this all, the form factors discussions and the width discussions all play back into the original discussion that Michael started when he started talking about the next rate. Okay, and if you look at market adoption, what we've seen is that the serial and the by-4 solutions have really been those that have been adopted. Okay, and forget the form factors, just saying in general, if you go and look at that. For example, a lot of the by-8 solutions for 400 gig really aren't ramping up as quickly as some would like, right? So I think that you can always achieve a higher speed through an aggregation of lanes, but then it comes back to the other point that Michael was making, what's the cost? And we're seeing this whole by-4 sort of thing. So I do think that as we start to talk about the next speeds and we start to talk about the widths, I don't know if the market is going to go to by-8 solutions. I think on Michael's roadmap, he had showed 800, then 1.6. That's one way of looking at it. In the conversations that I have had, people look at the per lane rate of 200 gigabit per second as really the key ingredient. And then, and that's really starting from the switching chip out, going from electrical to the optical world. And then you start to think about, okay, well, what am I going to put 200 in? Well, if I put 200 in a by-4, it is a 800 gig solution. Now, if I put 200 into a by-8 solution, the maximum capacity is 1.6. So you don't look at it as the speed of the Ethernet rate, essentially, in my world. I look at it as, okay, what is the lane rate? And then what can I get into it? Because what we're seeing right now in discussions is that people are starting to gravitate, and we're hearing more play about a by-8 solution. And by 8, I mean by a module for by 8, because they can then put in 2 400 gigs. So now it's a density play, all right? So it's not, you can't just look at it as a single rate. You've got to look through the applications. So now as we start to talk about 800 and 1.6 coming together, I see that next step not being 3.2, but I see that next step being 400 gig a bit per second per lane to get that 1.6 down into a by-4 module. Okay, so I those are my viewpoints. That's why I think this is a really interesting conversation, and we've got to bring all of this stuff together so people have a good idea of what they're, what's going on. You can't just look at it from one perspective. There are multiples that are happening.
We are, of course, asking the $1 million question. We don't expect to have the $1 million answer, because that would give us $1 million. But we all have a very interesting approach here. I saw a very interesting comment from Karen Liu from Lightwave Logic. So Karen, hello, how are you doing today?
Hey, Jose, good to see you guys.
It is great to see you.
I just wanted to follow up on the discussion. These are not my thoughts. I saw 2 very interesting talks in the last week, and when I put them together in context, I think it very much relates to what John was saying. One was a chart from Juniper, who I'm sure that, perhaps Jen will talk to that instead. I think I saw Jeff Mackey present a chart in which he showed the switch ASIC capacity over time, and then showed how the by 1, by 4, and then by 8 was actually required to keep up because the slopes were different. So maybe Juniper could speak to that one. And of course, I've looked at arrays for a long time, and one of the frustrating things has always been that photonics, as you know, has struggled with certain fundamental issues, and it's impacted the ability to build arrays in terms of both yield and then also in terms of failure. And so you needed to keep the granularity low for field replaceable units and so forth. For years, I thought, we were just stuck and there was no hope. But then I saw this talk from Facebook in which there was sort of a glimmer of hope, right? That the observation was, it's all this data, historical data we've had for decades are coming from direct mods. And now the world is different, right? So not that we're no longer abusing these laser junctions, right, in the same way. Maybe things can be more reliable. He's not seeing the same failures. once we go into, silicon photonics and external mods and possibly even AMLs.
In a previous online meeting, we had Vincent presenting about the reliability role in beyond 400G. So it was a great presentation. We have everything in YouTube. There is a lot to discuss on that very point. And I do think there are more points to be addressed, but everything is going to come together much more clear when we hear from Jim Theodoras. And Jim has been one of these souls that we connected during the online technology meetings. He got connected to so many EPIC members and he followed up with all of us. You are one rock star, Jim. Thank you very much, Jim Theodoras, for AG Genuine, for being with us today. What's on your mind?
Well, I first wanted to comment on the previous statement, and that was, yes, as you get wider, it's not just reliability, but also I call it the hidden cost of complexity. And it's not an exponential, it's a factorial. So I currently make a lot of transceivers that have four channels, and the odds that one of the four channels are marginal, and remember, this would be like in mass production at hot, at the ninth corner of low voltage and hot case, and everything is at its extreme, to get everything, all the stars to align across four channels really as dramatically to the end cost of the module. And these are hidden costs because it may not show in the BOM, but those yield hits are eventually given, do make their way to the end customer. So I cringe when I hear 8 channels, not because it's not doable, but and even not because of the component count, but just because my history of always trying to get 4 of something, for instance, in the CWM4 to yield out and meet customers' expectations on pricing, to try to do that with 8. Oh my goodness, especially when they're 8 different colors. Wow. Let alone 16. So it scares me a bit.
Well, let's see. If you ever need to do the testing of these devices, I can connect you with all the different companies from Rod Microtech to VLC Photonics. We'll make it happen. But indeed, if you are scared, a company like Genuine is scared to go to the 16 channel, then we all should be a bit concerned.
Yes. So it wasn't clear. Do you want me to pop up slides now, or do you want me to?
Yes, I want to see your presentation, because after this, I expect a really, really strong discussion. You always set the bar very high for a good communication.
Okay. Let me pull this up.
Nice cycling. I live in the Netherlands. When I see this picture, I feel represented.
Yeah, I'm showing that because my Zoom is updated and it's not showing the typical Zoom. So is that full screen for all of you?
Yes, crystal clear.
Okay, so just real quickly, so HG Genuine is not a common name. So just to briefly say who we are. So HG Genuine is the optical transceiver part of a larger company called HG Tech. It's based in Wuhan, China. And the parent company is listed on the Shenzhen Stock Exchange. A few years ago, they pretty much dominate the PON market in China, and they wanted to grow. And there's 2 ways of doing that. You can grow geography, or you can grow market segments. And they showed some courage and decided to try to do both simultaneously. So we moved into datacom as well as moving outside of China simultaneously, which was a bit risky, but I think it's paid off, and we're seeing a lot of success. So we just opened a new $100 million factory, just dedicated to 400 gig and higher speed Ethernet. This is just datacom. So our current 2 factories are full of PON and other things. But for datacom, we have a brand new factory. So this is the information we took over. It was an old building that was a printing press that made newspapers. And you think, well, how could you do optics there? Well, the floors could hold the weight of our machinery, and there was a lot of power available because printing presses took a lot of power. And it went from this dusty, old, moldy a newspaper factory to now being a state-of-the-art datacom factory, we have 14 100-meter long production lines, of which, remember I said that the cost of complexity, so our more complicated parts actually have 2 full 100-meter lines where the optical engine consumes an entire line and then the transceiver consumes an entire line. So that's a lot of equipment just to make a transceiver. So these are some pictures from the factory. These are screen grabs from the video because it's grown a lot since the lockdowns. And so I've not seen it in a bit. And these were some screen grabs showing that they're going full steam there. So we've actually pre-sold 60% of the capacity has already been pre-sold for the next 3 years with another 15% on allocation. So we're sitting about 85% capacity, and we're still finishing up production lines. So the point I want to make, this is actually one of Jose's slides that I've edited from our previous webinar, is that people think, oh, you build a transceiver, and you don't just buy parts and then build a transceiver. That would make you a contract manufacturer. To get these latest, greatest datacom transceivers, it's an entire ecosystem has to support that. So I talked a lot last time about the optical engines. So there's a lot of various technologies that go into making an optical engine work, but there's also the cabling, like you can't do a DR4 without a SENKO connector. The VCSEL technology needed to support not only active optical cables, but our highest volume part is an SR4, 100 gig SR4, just the sheer VCSEL technology that goes into that. And people often forget about the other supporting things, such as market intelligence, because we have to build and buy our parts way in advance of actually needing them. And we can't do that with the market intelligence reports. The testing, so I know, Jose, you bring up a lot about the testing capabilities of the EPTIC members, not just at the transceiver level, but I'm glad the topic of wafer scale testing came up, because I'm not sure how many of you know, but our end customers require us to provide wafer level test data, and we don't even make the wafers. So that means our end customer, before our hyperscales that buy our transceiver, they want to see in the cloud uploaded all the way back to, if we buy a TOSA, and then part of that's a laser, and that comes from another vendor that came from a wafer, the source wafer that ends up being our product, that data must be uploaded in the cloud, and there's these AI routines constantly sifting and sorting and giving that data and showing, is the process tight? Is the process still in control? And I can't sell a transceiver without that wafer level test data, even though I don't even make wafers. So I'm glad the topic of wafer level testing came up. It's an ecosystem, and I think all the members of EPIC need to come together and work together to create this ecosystem that's going to make these 800 gig and 1.6 terabit and, God forbid, 3.2 terabit transceivers. So I just wanted to quickly talk about, to know where you're going, you have to kind of know where you've been. And so this is a slide I like to show because it shows what we used to do, what we do today, and maybe what we're going to do tomorrow, because data center isn't just one set of datacom optics. There's different parts of their networks that have very different needs, which can get confusing sometimes. So I split them up into what's duplex, and protected by like 2-to-1, 3-to-1, and by protection, and then what has to fan out, because in one case you care about how much can I get on a duplex fiber and I still have to go pretty far. In the other case, you can about, I've got to touch as many ports as I can. So this is what we used to do, what we do today, and where we're headed tomorrow. And I don't want to spend too much time on that. What I want to do is instead jump to this. Because if I really put on, and this, this is EPIC, so I've got to put on my really longer term hat and say, where's this headed, so that we make the investments in technologies today, so we get to that 3.2 terabit. And that is, there's this divergence in what's needed for the data center. And we saw that 10 years ago. John walked all of us through that when the optics need diverged from telecom, also meeting datacom, to, you know what, datacom needs something a little different than telecom. And today we have two different product sets. I think that's happening in data center optics as well, to where everything in green here is, you know what, I need duplex connectivity, I need to go distances, but I still need, I still need a lot of bandwidth and speed. And that's very different than below. In yellow here is I need to touch as many ports as possible because I need what's called fan out. It's known as breakout in the industry, but to me it's fan out. You want to touch everything. And so as I put on my long-term hat, here's my dunce cap, I see coherent eventually is going to meet most of these needs, which is good for EPIC members because we've seen all these phenomenal technologies that's going to play into 400, 800 gig ZR coherent. And then also anything that must fan out wide for these AI and these switch matrices. And I mean, Google now is making these fan outs torides again, just like the old Cray supercomputers used to be, which I find really ironic, but it's cool too. That is going to be, maybe not CPO, maybe not COBO, but it's going to be something very much like it. It's going to be something co-packaged, something integrated. And again, this is great news for the EPIC companies because all those technologies are going to be needed to get to that level of integration. So that's why I'm glad when we're talking about the polymer modulators, it was brought up drive voltage because it's not just about the switch power. It's not just about how much power the modulator needs. It's also the overall channel power. And so co-package gets rid of driving a trace on a board. Okay, I've saved some power, I removed a driver, but there's still drivers for the modulators. Okay, going to low drive modulators, okay, I got rid of those drivers on these little chiplets on my co-package. Now I can drive straight from the Tomahawk, but there's still SerDes on the Tomahawk, driving probably 75% of the power of the Tomahawk. So, well, my drive voltage got even lower down to like a, to logic levels. Now I can get rid of the SerDes. Now being fully integrated makes a lot more sense because I'm switched straight driving into what's going to make my optical signal. And then maybe that makes sense. So, long story short, this is good news for all the EPIC members. I think we all need to come together and make this a reality. And I think we have all the right talent on these calls. And thank you to EPIC for driving this and making this a reality.
No, thank you to you, Jim, for giving these extraordinary presentations. Okay, so then I like it very much the slide in which you put our parts of the supply chain, at least the parts of the supply chain in which you are interested for developing your transceivers. So let me focus on this because probably you are working with, you need software, right? Software
Yes.
for designing. Okay, so we have here Aura from Synopsys. Aura, are you here?
Yes, hi, Anna.
And maybe, do you think this is a good opportunity for you to talk about which are the capabilities of a Synopsys software? And maybe, do you have one slide?
Yes, of course. Let me perhaps share my screen. If you can see this one.
Yes, but this is the node mode. If you can, now, very good.
Yeah, now you see the normal one, right?
Yes.
Okay, perfect. Yeah, as it was mentioned, getting into the ecosystem, all the parts is really important. One of them is software. So hi, everybody. I'm Aura. I'm working at Synopsys Photonics Solutions, and I'm a technical account manager. But without further ado, let me introduce you the Synopsys industry's first unified PIC design platform. So actually at Synopsys, we are accelerating the adoption of photonic and PIC technologies with software to design and manufacture energy efficient, high performance photonic devices, systems, and integrated circuits. So the photonic solutions portfolio that we have offer a seamless design flow from concept to manufacturable design, and it is supported by photonic experts, as you can see on the slide. So with Synopsys software, all the design teams have access to a widely used, high-quality electronic and photonic design solutions from a single provider and with a single support channel. And you can see here our newly unveiled product, which is named Optocompiler. This is the electronic photonic cockpit of Synopsys, and it offers an interactive environment enabling electronic photonic co-design from schematic to the layout photonic aware curvilinear layout synthesis, and a complete solution from concept to validated and verified mask. So this is quite an important step on the peak value chain. And of course, if you are interested, please contact us. So we will be happy to support you on developing your photonic design flow.
Thank you very much, Aura. So, okay, so now we have the software. I would like now to go for the packaging, and we have here today a company, vario-optics, and we have here Nikolaus. Nikolaus, are you here?
Hello, yes.
Okay, so can you tell us a little bit about your capabilities for packaging, and maybe you also have one slide to show?
Yes, I hope you see my slide here.
Yes.
So thanks for this opportunity. We are at vario-optics, we are developing and manufacturing electro-optic circuit boards. So this is a platform that can be used to couple PICs to the outside world. On the one hand, you can, for example, think of a PIC that you want to interface with a fiber array, but as you see here on the left, you could also think of a more complex board with more than one PIC. And what you need then is a way to optically communicate between these PICs. So our solution here consists of an electro-optic circuit board platform. That means you have a PCB, you can also have a rather complex electrical circuit. And we add on this our planar waveguide technology based on polymers, which can be used as fan-out structures. They can be used to efficiently couple to the PIC by changing the pitch or the mode field diameter. And all of this, you see it here on the right, really enables this complete platform of having a simultaneous electrical and optical interface. So this is an example that we realized in a consortium. You see a zoom in here of the area where the PIC can be mounted. And you see finally, you see a fully assembled device here with a flip chip bonded PIC that is used here, and that results, so our partners have measured here nice data rates, also with very low power consumptions. So what we offer to answer these EPIC questions to the EPIC members is really this complete platform of having an electro-optical circuit board. And what we are looking for are partners that have chips that have an application in mind and that need such an innovative and versatile packaging platform. So if you feel like you are in this region, you feel free to catch up and get in contact with me.
Thank you very much, Nikolaus, for this slide. Okay, yes, of course, if any of the companies making transceivers want to contact with vario-optics or also with Synopsys, we will be very happy to make the introduction for you. And now let's go for one of the questions that is in the chat. So we have Chris here from CTA. Chris, would you like to ask your question about volume capabilities? Okay, I don't see Chris here, but Jim, what about your production capability for 100G and 100 and 400G in these new facilities?
Sorry, I was on mute.
Ah, hello, Chris.
Here I am. Hi, Jim. How are you?
Fine. How are you doing?
Not too bad. So I was just congratulating you on your new facility, and I don't know, because one of the big topics that we always have. I've lived in this space for quite a while. CTI right now is my consulting company. I'm advising a few companies in the transceiver space. But one of the big challenges we have on the transceiver side is always the substantial upfront investment on CapEx. And I just saw you mentioned on the order of $100 million to get ready for the wave of 100G and 400G modules. Can you share roughly what capacity that translates to?
I don't think it's public information yet, and we are publicly listed, so I will have to be cautious. I will say we have the capability of doing 500,000 CWDM4 modules per year, and that is not even half of that factory. So there's a lot of capability there. And when I say 100 million, obviously that's wasn't something where you walked into a bank and just got that money. it's done the same way that most governments do it, where if you can show there's investment, it's released in trenches. If you can show you're hiring people and you're building something that then benefits the economy, and you're buying equipment locally, things like that. So I think we've burned through about 85 million of the 100 million credit line, and we have most of the 16 lines in. So we're just kind of getting going there. But we do have a 100 gig SR4 line running full speed, and we have the CWM4 line running. But when you run that many parts that fast, you got to do a requalification of the parts to qualify the process that makes them, not the parts or design themselves. So that's currently ongoing. It takes at least 2,000 hours on a large statistical sampling to do that. And we've had already had hyperscale auditors come through because they use a lot of CWM4 parts as well in active optical cables. And our SR4 is the basis for our 100 gig active optical cable. So I guess it's a long way of answering, can't tell you, but I mean, we're easily 1 million parts a year, and that's probably not the full capacity.
Sure, no, thank you. I think it's also good to illustrate for people who are maybe not as close to the action on the production side on what these substantial investments are. And first they all have lead times, and then you have all the quals, you do your own quals, and then the customers want to do the quals. So this is always a massive undertaking. And sometimes when we talk about all the different generations, we lose sight of what that does to the manufacturing side at the tail end before you can actually roll the product out the door.
Yeah. Thank you, Chris, for bringing that up. And Anna cut me off if there's not time for this, but it's important that everyone does understand that process you just brought up, because we have to buy the equipment long in advance. And then when the equipment does come in, it just doesn't do what you need. You have to build a fixture and write software to make it do what you want. And then when that's even running product, you're not allowed to sell that to customers. You then have to what's called close the process, to where you run enough product that statistically you have a meaningful data set that shows everything's repeatable. And then you've got reliability. And even when you're at that point, you have to start bringing in auditors, because even if it's the same part you made somewhere else, they want to audit the process to see that it's tight. And as I mentioned earlier, they even now want to see your wafer scale data, even when we don't make the wafers. So it's there's a lot involved. It takes a lot of planning, and that's why I brought up also earlier. It's important these industry consultants and data that are plotting and charting the future help us pre-plan. So obviously the lead time on these machines can be a year or more. So we have to pre-plan in advance and get the credit lines and things like that. It's a very complicated process. And I really thank you so much for bringing that up so that the EPIC members can understand all that's involved.
But we are not done, because I still have another company to introduce to you. Wilfried from SUS MicroOptic. How are you doing?
Good, very well, thank you. I had to laugh when I saw Jim's slides about the newspaper factory, because that's what we just did. So we got an old building from an old newspaper factory and got our equipment in there. I just like to share a slide or two. Is that okay? Or
Yes, go ahead, please.
So
one slide, please.
One slide. Okay, when I show one slide, then I show this one. And I don't know if you see it. Can you see it?
Yes.
Oh, sorry. This is what we offer. So that means, so we realize that in micro-optics, we're doing micro-optics for transceivers. So for telecom, datacoms in 15, 20 years now. This is nothing new. But what we see is all this packaging issues. So that's why we try to integrate more and more features for packaging. So this is all known for CWM4 and for Prism. But we also offer all of these things in the front and back side. But we want to also show actually what is the future, we believe. So this is integrating mirrors directly into the silicon. And we're also looking into other materials now where we can directly integrate a 90 degrees mirror into the micro-optics. And the question is, if this is something that co-packaging optics needs or not. So this is still something I would like to do with different companies who offer co-packaging or looking for co-packaging optics. This is basically my question. How does the community see this? So the technology is out there. It all has to be requalified, like Jim just pointed out. So you can't just come up with a new product and then it might work or might not work. So there's a long way, of course. But I think we are still not at the end of what can be integrated in a single device. So for now, MicroOptics was just lenses on a slab, but now we can integrate more and more features, just like you do on the PIC. And there is where we're looking for more cooperations with other companies in the transceiver business. Thank you, Anna.
Okay, thank you very much, Wilfred.
But this is a very, very important question. This is a very important question. We have great technologies on micro-optics at wafer level and also with two-photon polymerization. I think multi-photon optics, my friend Ruth is also in the room. We have great technologies to do micro-optics and bringing the optics very close to the PCB board. Is that something needed? Is there more high-end or more know-how on the micro-optics? Jim, what do you think? Is there a need for new approaches for the micro-optics, bringing them into the co-packaging?
Yes, because the amount of things we're squeezing into the traditional transceivers is growing dramatically, and yet the size of the transceiver hasn't. And so you need something other than the full COBO PIC. Because transceivers, despite my graph showing everything's going ZR and CPO, that's the long-term vision. There's a long future for transceivers, and we just can't put any more stuff in our TOSAs, ROSAs anymore. We currently use Z prisms, discrete Z prisms, and 45-degree prisms. And there's just not room even for 4, because you have 4 in the TOSA, 4 in the ROSA. It's 8 channels squeezed into the width of an SFP. It's just definitely.
I'm very interested in the views of. I'm very interested in the views of Odeda, CEO of Photonics Networks, because a couple of years ago he thought there is a big business on the complex packaging of VCSELs. And now that all these micro-optics technologies are really booming right now, is there a process or is there an idea that you have to add this to the packaging technologies of Photonics Networks for VCSELs?
Yeah, hi Jose. It's a fantastic opportunity, but also it's a very well organized workshop. So congrats on this. I think Photonics is looking at this slightly from a different. I'm very impressed with the slide just shown by SUS MicroOptics, but we're looking at this as a silicon bench kind of solution. We are seeing that there's a need for a platform, and you have different ways of packaging optics, of course. But we have started by looking at VCSELs as a main platform for integration. Maybe I can share a slide. Maybe I can.
Always, Oded, always. Go ahead.
Yeah, I'm just trying to figure out which one is the best to do. I think this should work. I'm not sure it's the highest resolution, but I'm afraid to press any button in fear of losing what I now have on the screen. So
go ahead.
So you just see what I'm showing here. So basically, we have looked at this originally from the research perspective, and we found that silicon has a lot of very, very attractive proposition, as the people in SUS can definitely, of course, vouch for. It's a very robust technology. It offers a lot of opportunities for processing. I mean, there's a whole field of foundries doing MEMS processing. And what we think is that silicon is really an exciting platform compared to ceramics or all the very complicated PCB materials, which are organic based or others, to create these platforms. We can do all this packaging. We can trace all these high speed traces. We have really nice data showing the speed is really up there at 56 gigabaud, 112 gigabits per second with PAM4. And we can really do very massive parallelization. So we demonstrated 48 channels, of course, 48 channels. Nobody's even dreaming about it. And I really like the comments about reliability and the complexity of increasing the channel count. This is definitely not a linear complexity problem. It's definitely, as we know, yield anyway is an exponentially degrading thing. If you have 99% on one device, try calculate it for 16. But we are really optimistic about this, and we really think that the way to go is some sort of silicon interposer, maybe with V grooves, like the guys in the SUS are looking at. So these kind of solutions are really interesting.
Congratulations, first of all, on how you are really helping all the VCSEL community interacting with the companies who really need the complex packaging of VCSELs. But I'm also going to push a bit more, if you allow me, Odette, on the micro-optics part, because I'm super excited with what is happening and I really want to understand it a bit better. We have a company in Epic, a company that is a petrochemical giant. The company is called Savic. And when I went to visit them, they told me, no, we also do optics for packaging of transceivers. And I was, okay, what is the link? Gabri from Savic. Gabri, I want to know your vision, and also I want you to dream away of your preferred future for the optics needed on the packaging of these co-package optics.
Yeah, thanks, Jose. Yeah, that's correct. I mean, we sell plastics for the pluggables, but we also can sell plastics for the onboard optics, especially the plastics that have reflow capable materials. So my question is this interesting for the industry?
And that's also my question. And it's difficult always to have an answer. There is interest. There's definitely interest. So why don't we go to our friend from Juniper Network? Why don't we go to Juniper Network? We had a really interesting presentation a couple of, half an hour ago. And you talked to us about different concepts on the 100G and 400G. We have great technologies for adding optics on the top of silicon, for bringing the optics very close to the electronics. We manufacture them at wafer level, very reliable, with suitable to high temperatures. Is there a need on the industry for these optics?
Oh, I'm not sure I understand the question or not.
We have great optics. We have great optics, and my members are telling me, I hear a lot about co-package optics. I hear a lot about this. I want to know about the optics part of the CPO. I want to know about what kind of optics they require for the co-package optics.
For co-package, I think still need some time. Currently, we are talking about the 800G, right?
Yes.
Sorry about. Yeah, we're still. It is still. We talk about 2x. It's still the pluggable. So for co-package, I'm not sure. Sorry about it. Yeah.
No, but I just don't worry, because nobody is sure. So I'm going to ask some of the people in the room to see what is their vision and their need for high-end optics, wafer level optics, and even printed optics for the packaging with integrated photonics. Let me go first to Lightwave Logic. Let me start with a polymer foundry. Let me go to Michael Lebby. Michael, you have seen, especially in Europe, a boom on micro-optics manufacturing. Is there a need on the packaging of integrated photonics, especially in the co-packaging, which seems to be the future?
Well, I think the general answer is yes. And the reason I'm saying yes is that we haven't seen all the solutions yet over the next decade. What we do know is that we've got to figure out things in a more miniaturized format, whether it's pluggable or otherwise. I don't think that really matters. What does matter is that we've got to get light in and out of the situation using different techniques. And whether it's going to be on board with different layers and waveguides in a silicon photonics or indium phosphide, that's certainly going to be one solution. But we'll also need micro-optics, because we'll want to simplify how the light gets to the fiber. And everybody has their own solutions to do that, whether it's a grating solution or a buck couple, or you've got some transition from one waveguide to another waveguide. I think you're going to see a whole portfolio of optical solutions, which is why it's sort of exciting. There's no one single solution that is the right solution. Everybody's got to design for, look, all of us have been in the optics business for a long time, and it's really easy to lose light. One of the most difficult things is to not lose light. I mean, if we've been in a lab, light just goes everywhere. And so micro-optics is a key component that's going to help us preserve the light. And so if we can preserve the light, our optical budgets are going to be better, and everything becomes easier. So it's going to be important.
So for me, what I have seen in the last 10 years is two tendencies. On one hand, the tendency of bringing active alignment to a fast speed, so it's as fast and as low cost as passive alignment, and on the other, the opposite. On the other, trying to do everything at wafer level, trying to do the wafer level packaging, the wafer level optics on the packaging, try to align them passively. I want to understand this a little bit better. So I'm going to ask a company that we have as a player on the passive alignment in EPIC. It's called ficonTEC in Berlin. Herman, you have seen the same thing, the tendency of doing everything at wafer level and at the same time companies going into active alignment of components individually. From the point of view of ficonTEC, how is this co-packaged optics industry going to look like?
So it's a good question, Jose. Truth to be told, actually, we can see both directions being followed. It seems companies have totally different philosophies on that. Some are really saying, okay, we're going for the active alignment. Some others say, okay, we are buying an equipment that is super precise and we're trying to do that in a passive way. As you know, the active alignment is not really our cup of tea. This goes to our colleagues in Achim. Whereas our focus is on the passive alignment. So as that, typically we don't touch each other much in the field because companies going to this field with a totally different approach. Everybody thinks that his approach is the right way to go. So what we are doing basically is to support our customers that decide to go the passive way. And yeah, as I said, trying to support them by trying to build some samples for them and probably trying to develop the process with them.
Thank you very much, Herman. I honestly believe there is a huge room for cooperation here, and I do love when companies go into wafer level. I'm going to go to a friend of mine, a very dear friend of mine. I'm going to go to Gloria Infinera. The reason why I'm coming to you first is because I like you very, very much, and second, because as a foundry of indium phosphide chips who managed to go all the way up to the value chain to sell optical networking systems for data centers and telecom operators. Gloria, how do you see this? Co-packaged optics is the future. Do they need extra different, more difficult, more complex optics to make that future possible?
Thank you, Jose. I think that the issue of co-packaging and the alignment and all of those related packaging constraints really are very much application dependent. I think, as Michael had mentioned, you can't lose photons. It's very, very, they're very expensive to make, and so efficiency is really critical. But it cannot come at the cost of adding more cost, either by slowing down the alignment process, which is one of the areas that you have to fight in active alignment, or by losing photons, which is essentially what you do when you do passive alignment, especially in indium phosphide, which is more what we do. So I guess the answer really is it depends on the application. Low cost applications will continue, I think, to be looking more for passive alignment. And in the issue of co-packaging with the electronics, especially, you have to be looking at athermal solutions. So at Infinera, we have done a lot of micro-optics in our packages. They're some of the most compact modules and DCOs in the industry. And I think it can be done. It really just depends on the cost and the application.
There is a lot of room for cooperation. Gloria has been a great entry point for EPIC members into potential discussions with Infinera. Thank you very much, Gloria. I want to understand a bit better, and the best way to do it is to talk to the semiconductor manufacturers, the electronic ICs manufacturers, the ones that are talking CMOS business. And for that, we have AEM in the room. Thank you very much, Harshan. And thank you also, Jim Theodoras, for making this happen. Harshan Pandya is here from AEM, the general manager. Thank you very much for being with us. The floor and the attention of everyone for closing this spectacular meeting goes to you.
Thank you, Jose, and thank you for giving me the opportunity to close this meeting. Let me try to share one of my slides if I can. Can you see my slide?
Yes, crystal clear.
Okay. So AEM is a Singapore-based publicly listed company, which is focused on system-level test handlers, like very large-scale device testing handlers. And also we have test solutions, test and measurement solutions. Just give me a minute. So some of our products, as I mentioned, this is on the left, what you see is the system level test handler solution, which is capable of doing massively parallel testing of large number of devices. In most cases, we have customers who have their own test systems that get integrated into our handlers, but we also have possibility to provide test solutions for specific devices, and the devices range from semiconductor chips, very complex chips, to even modules, right? So we have a wide range of DUTs that get tested through our handlers. In addition to the system level test, which is the larger business unit, we also have a facility in Finland where we do MEMS testing at wafer level, mainly for the sensors. So pressure, gyroscopic, accelerometer sensors, and so on. And then the third business unit that we have is test and measurement solution, where we make vector network analyzers for RF testing. We focus particularly on passive devices like cables. So both fiber optic and copper cable testing, including single mode and multi-mode fiber optic certification and category copper cable certification. And we also have solutions for automotive and 5G infrastructure cable testing. Okay. Just to give an idea about one of our recent introduction of test here, this is a multi-mode fiber bandwidth test solution. So when multi-mode fiber is used, one of the challenges, of course, is the DMD, which severely restricts the bandwidth capability. And we have a solution to measure the bandwidth of multi-mode fiber cables. But our test solution basically covers more on the enterprise side for testing all applications that go with Ethernet networks. Thank you.
Thank you very much. Thank you very much also for joining this event and for presenting this presentation. What do you think in terms of collaborations, the companies that you saw at this meeting, the different talks? What will you be the perfect partners for you to collaborate from our industry?
Yeah, I think like I mentioned, our system level test handlers provide I think a very good solution for testing devices in large quantities, and we can collaborate in terms of making specific test systems per cell, or we can also incorporate customers' testing environment. One thing I did not mention is that our test handlers can also provide thermal excitation, so like heat and cooling. Extreme temperatures, so you can subject the DUTs to different environmental conditions while performing the test, right? So I think the opportunity is to collaborate with device manufacturers to provide testing for the post-production testing system level.
Okay, thank you very much. So maybe I would like to introduce you one of our companies. That maybe you could think about a collaboration. So we have here Denselight.
Mm-hmm.
So I don't know if
hi.
Hello, how are you?
Yes, hello.
And maybe it's a good moment for you to present the capabilities of your company, and maybe do you have a slide?
Yeah, okay, I can share slides. Just give me a moment. And
okay,
so,
yes, if you can go to presentation mode.
Yeah, okay, so just hold on, let me get to share the right screen. So screen 2. And I'm going to go into the presentation mode. Okay, right, you should.
Yes, very good.
Okay, yeah, thank you. Hi, hello, my name is Eloy from Denselight. Denselight is an indium phosphide device supplier with vertically integrated indium phosphide fab from epitaxial growth to device fab and testing, actually located here in Singapore together with AEM. I think for today's session, I'd like to take the opportunity to introduce our D5 or Denselight Photonics hybrid integrations, which is a one-step integration service for indium phosphide laser onto silicon photonics optical engine. So on the left, we show the manufacturing flow whereby the Denselight indium phosphide lasers or gain chip or the SOAs are passively align and flip chip onto silicon photonics wafer. And this wafer comes from our partner Silicon Foundry to create ready-to-use optical engine. So in this slide, we illustrate an example of a 400G optical engine for DCI. And as you can see, it can be assembled into pluggable transceiver, or it can be chip mounted on board and as a photonics engine. So lastly, I'd like to mention that Denselight is platform agnostic in supporting our customers' indium phosphide needs. So for instance, our suite of laser solutions support both the remote and integrated laser COBO architectures for data centers, interconnects, and switches. Thank you.
Okay, so thank you very much. If any of the companies present here that are here in the meeting want to contact the Denselight, please drop me an email and I will be very happy to make the introduction. Okay, so then if there are no more comments, so then back to you, Jose.
Thank you very much, Anna, for this. I do have a lot of comments. But what I want to say, first of all, to all of you is that this meeting only lasted 2 hours. It could have lasted several days. It will last for 2 days soon when we can travel again, and I cannot wait. And we had the meeting at Microsoft because Microsoft has told us that we're going to have a 2 days meeting for the EPIC members in Seattle at the headquarters. All of us together trying to understand this and bringing the high-end data center and telecom operator. It's going to be epic. I don't have a date yet. I'm dying. There's a virus going on out there. We're going to kill it, we're going to beat it, and we're going to have this amazing meeting at Microsoft. I want all of you there. It's going to be epic. I cannot wait to have a beer with you. It's been a great meeting. And I know that all of you are going to say, well, it was epic meeting. Of course, it's going to say it. It was a great meeting because we had high-end companies telling us about their needs, and we did understand that we don't know where the industry is going. And that was clear. We had a beautiful roadmap slide from Michael Lebby, but we had a lot of different options and maps and how many channels are we going to multiplex? Are we going to go to onboard optics yet? And now we're going to stay with plug out for a while. Is this an intermediary step anyway? Regardless, there are a lot of business opportunities here, and companies are going to get in touch with each other. Why? First, we talk about fast modulation. Lightwave logic, Michael Lebby told us, I think the polymer is the way to go. There are, of course, other approaches, but we need fast modulation. That's clear. The second one is, do we need micro-optics at wafer level? And all of you, we had a really beautiful round. That was, for me, the highlight of the meeting. All of you agreed that we believe so. So let's explore that, because we had the best micro-optics right now in the EPIC network, the best micro-optics in the world, and we need to push that. The second one, it was clear, wafer level packaging and die level packaging. And the wafer level packaging is, of course, the challenge, but the testing at wafer level is one of the enablers of that challenge. And for that, we have seen in the last years huge developments on that. And what I want to say also is that this is just a part of what's going to happen now. Because for me, introducing the companies is just a way of life. Introducing the companies and making people happy for working together is what I do for a living. It's what the EPIC people do for a living. So remember, if you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asset.com, jose.pozo@epic-asset.com, and I will make that introduction. On behalf of an amazing team of EPIC members and EPIC staff, I would like to wish all of you, first, be ready for the best and prepare for the worst. We don't know what's going to happen, but always be epic. Join the EPIC meetings. We have a great selection of topics for the coming weeks until Christmas, and we're going to continue. I can already tell you that after Christmas, again, 2 meetings per week, always looking for the end users and understanding what they need. Until the next time, remember, from the beautiful city of Northright, just next to the beach, with a little bit of voice left, all my energies go to the Epic Network. Have a really fantastic day. Good night, everyone.